Hello everyone. In this session, we will see Phasor and Phasor Arithmetic. Phasor. A phasor representation of a sinusoidal quantity. Sinusoids are represented in phasors. Phasor is defined as a vector used to represent a sinusoidal function. And this vector rotates about the origin with an angular speed of omega, radian per second. So phasors are also called as rotating vectors. Consider a phasor A, magnitude A, rotating at an angular speed omega radian per second in anti-clockwise direction. The vertical projection of phasors at each angle is made on the vertical axis, and when it is drawn connected, we will get a sinusoid. Representation of phasors. Phasors are represented in four forms: rectangular, trigonometric, polar, and exponential. Rectangular form. In a rectangular form, a phasor is represented by z is equal to x plus or minus jy, where x is the positive real axis term, and y the imaginary axis term. The magnitude of the phasor is given by z is equal to square root of x square plus y square, and the angle is given by tan inverse of minus y by x. In trigonometric form, the phasor is represented by z is equal to r cos theta plus or minus j sin theta, where r is equal to square root of x square plus y square and theta tan inverse of y by x. Polar form. In polar form, a phasor is represented by z equals r angle theta, where r is the magnitude, which is given by square root of x square plus y square, and theta is the angle, which is given by tan inverse of y by x. And the last form is the exponential form of phasor representation. In exponential form, a phasor is represented by z equals r e raised to j theta, where r is equal to square root of x square plus y square and theta equals tan inverse of y by x. Moving to the phasor addition and subtraction. The phasor addition and subtraction are done in the rectangular form. Consider two phasors, phasor A equal to ax plus jy, and phasor B equals bx plus jby. The sum of the two phasors. In order to find the sum of the two phasors, add the real and imaginary terms separately. That is, the new phasor C equals cx plus jcy, which is equal to ax plus bx plus j times ay plus by. That is, cx is equal to ax plus bx. Cx is equal to ax plus bx, and cy is the imaginary terms there. Sum of imaginary terms of the phasors A and B. Similarly, the difference of phasors. Subtract the real and imaginary part separately. That is, the phasor C is given by cx minus cy, which is A minus B. That is, cx is the ax minus bx and cy is ay minus b. Now the phasor multiplication and division. The multiplication and division of phasors are done in polar form, which is the easiest form to perform the multiplication and division. Consider two phasors, phasor A, which is equal to r1 angle theta 1, and phasor B, which is equal to r2 angle theta 2. The product of two phasors, that is, C equals A into B, that is given by r1 times r2 angle theta 1 plus theta 2. So the product of two phasors is obtained by multiplying the magnitudes, and the angle is the sum of the angle of the two phasors. Similarly, division of two phasors. Consider the phasor C, which is given by the phasor A divided by phasor B. Now in this, The division is R1 angle theta 1 divided by R2 angle theta 2. That is given by R1 by R2 angle theta 1 minus theta 2. That is, so in case of phasor division, we divide the phasors, magnitude of the phasors, and the angles are subtracted. So kindly note, the phasor multiplication, the magnitudes are multiplied, angles are added, while in phasor division, the angles are divided and the magnitudes are divided with while the angle is subtracted. Thank you.